Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from sample paper number 7, BALI navigation book. The last 10 questions left, question 91 to question 100. So let's start. 91. How many feet you have to climb to reach flight level 75? Departure aerodrome elevation 1500. QNH 1023. ISA conditions 1 hectopascal 30 feet. So flight level 75 is 7,500 feet. Okay. So let's draw this diagram. Airport is 1,500 feet. Let's say this is your airport. Okay. This is your standard pressure setting 1013. This is your mean sea level QNH 1023. Okay. The elevation of airport, which is 1,500 feet will be measured from QNH 1023. Okay. Now you are to reach flight level 7,500. How many feet you have to climb? So 7,500, level 7,500 will be measured from standard pressure setting 1013. Okay. So 7,500 is from with respect to standard pressure setting 1013 pressure level. Elevation of this airport is with respect to QNH 1023. Okay, is with respect to QNH 1023. So now we have to calculate that difference between these two vertical distances. How many feet you have to climb to reach flight level 75? So let's calculate the vertical distance of this airport from standard pressure setting. Okay, so once we calculate that, we will compare that vertical distance of airport with respect to standard pressure setting 1013 and vertical distance of this aircraft with respect to 1013. So this we have 7,500, that's fine. Now let's find out this. Now this entire thing is 1,500. From that big value, we are going to eliminate this small value, this height difference. Okay, we are going to eliminate this height difference in order to find out this pressure altitude of airport. Okay. Now pressure difference is what? Pressure difference between them is equal to 1013 minus 1023, that is 10 millibar. We know that 1 millibar as given in the question is 30 feet of height difference. So 10 millibar will be equal to a height difference of 10 into 30, 300 feet of height difference. 300 feet of height difference. So what will be the pressure altitude of airport? 1500 minus 300, that is 1200. 1200. Now, how much vertical distance, that is feet, to climb from airport, which is 1200 feet. Okay, is from 1200 feet से लेके from this point from 1000 to 7,500 feet. So how much vertical distance? So 7,500 minus 1,200, you will have to climb a total of 6,300 feet. 6,300 feet. Okay, so distance is 6,300 feet. So that much height or altitude or pressure altitude of flight level you will have to climb. Next, the time to reach the closing level at a given gross mass is 36 minutes. Horizontal distance 157 nautical miles in nil wind conditions. So you are flying in calm atmosphere. You are flying in calm atmosphere. Distance is 157 miles. Time is 36 minutes or 36 divided by 60 hours. So your true airspeed, which will be equal to your ground speed in this condition, since you're flying in calm conditions, will be equal to distance by time. So 157 into 60 divided by 36. So 157 into 60 divided by 36 is 261.6 or approximately 262 knots. Step 2. In the course of your journey, you are getting a tailwind of 60 knots. You are getting a bonus of 60 knots. So tailwind of 60 knots. So when you get a tailwind of 60 knots, your ground speed will be equal to true airspeed plus tailwind. So what is true airspeed? 262 plus 60 is equal to 322 knots. So, okay, so ground speed you have, time is same, 36 minutes. Now distance equal to speed into time. So 322 multiplied by 36 divided by 60. So 322 multiplied by 36 divided by 60 is 193.2 nautical miles. Okay, so answer is 193 miles. Course 040, through airspeed 120, wind speed 30 knots. Maximum drift angle will be obtained from a wind direction of what? So they are talking about maximum drift angle. Now maximum drift will be produced by a crosswind which is coming from an angle of 90 degree to your track or to your course. 90 degree to your track or course. Now your course is 040. So let's say this is your north datum. This is your course 040 and the reciprocal of which is 220. Okay. So a wind direction which will be completely perpendicular to your course. So which will be at 90 degree to your course 040. So it will be like this or like this. A wind coming from the left hand side. So 40 minus 90 plus 3 plus 360, 310. So the wind should come from either 310 degree direction or 40 plus 90, that is 130 degree direction. Either of these directions you will get maximum drift or maximum drift angle. So select that option which is closest to this value 130 or 310. Okay. Main thing to understand here is maximum drift angle means maximum crosswind coming at 90 degree to your track, perpendicular to your track. Next. The hysteresis error of an altimeter varies substantially with aircraft altitude, time passed at an altitude, Mach number of aircraft. So hysteresis error is like an inertia. The more time you spend at a straight and level at a level altitude, okay, so that much your altimeter will be affected by hysteresis error or inertia. So if you, let's say if you spend too much time at a fixed altitude of 5,000 feet and then suddenly you change your altitude from 5000 to 6000. What will happen as you go from 5000 to 6000? There will be atmospheric pressure change. Your atmospheric pressure will decrease in value. But since you have spent long amount of time at same altitude of 5000 feet, your altimeter aneroid capsules will consume or will get delayed in registering change in atmospheric pressure as you climb from 5000 feet to 6000 feet. Okay, this delay is because of this hysteresis error, lag error, or inertia. So your aneroid capsule will take some time to register a change in atmospheric pressure. Okay, so that is why by time passed at a given altitude, hysteresis error. So the more time you pass at a given altitude, more the magnitude of this error. Next, distance from departure to destination is 400 miles. Wind component plus 30 knots, and wind component from Quebec to Papa, that is destination back to departure, is minus 40. Means coming back home, you are getting a headwind of 40 knots. All engines operative task is 160. Flight fuel 2450. Endurance 4 hours. Calculate distance to calculate distance to critical point and time to critical point for reduced task of 130 knots after one engine fails. After one engine fails. So let's say this is your departure, this is your destination, and here is your critical point. Now, starting from departure, all your engines are working completely fine. Okay, so your task will be normal task, which is equal to 160 knots, which is equal to 160 knots. You are getting a tailwind of plus 30. Okay, in the start, you are getting a tailwind of plus 30. So your ground speed will be equal to 160 plus 30, that is 190 knots. Now, at this critical point, you experience engine fail. So from this point onwards, you will be flying at a reduced cruise airspeed because now you have only one engine. Previously, you had two engines working perfectly. So what will be your so when your engine fails at critical point, you have two options: continue to your destination or come back to your departure airport. Okay, you have two options. Okay, so true airspeed, reduced true airspeed will be 130 knots. Now coming back, you're getting a headwind of minus 40 knots. You're getting a headwind of minus 40 knots. That means your ground speed will be equal to true airspeed 130 minus headwind 40. So 130 minus 40 is 90 knots. Okay. Now, formula for distance to critical point is total distance between departure and destination multiplied by homebound speed, outbound plus homebound. So total distance between them is 400. Inbound speed is 90 knots. Outbound speed is 190 plus 90. 280. 400 into 90. 36,000 divided by 280 is 128 nautical miles. Time to critical point will be what? Time to critical point. That means from departure towards critical point, what will be the time? Distance divided by speed. So distance is 128. What will be the speed going towards critical point? Your true airspeed will be normal true airspeed. All your engines are working. So 160 is equal to 48 minutes, approximately 48 minutes. Okay. That's it. Next. Typical airborne weather radar is stabilized within limits pitch, roll, and yaw, pitch and yaw, pitch and roll. So, theoretical question. Your airborne weather radar is stabilized around pitch axis and roll axis. Do watch my lectures in which I have solved all airborne weather radar questions from Oxford, Keith Williams, R.K. Bali. Also, I have marked important questions from airborne weather radar chapter in Oxford. So, do watch that video lecture and mark the important points and keep revising those important points again and again for your exam. 97. The basic elements of satellite system is space segment, earth segment, user segment, space segment, control segment, user segment, space, control and clock. So the correct answer here is option Bravo. The space segment, the control segment and the user segment. What is the purpose of control segment? To control the use of satellites, to maintain the satellites in orbit, to monitor the satellites in orbit. So the control stations which are on the earth, they monitor the health of the satellites. Okay. 99. If one static port out of two is not calibrated for position error, what will happen during high speed cruise flight? So remember, a position error will always result will always result in your altimeter under read. Okay, whenever there is position error, your altimeter will always under read. So the non-compensated altimeter will indicate a lower altitude. The non-compensated altimeter will indicate a higher altitude. The non-compensated altimeter will indicate correct altitude. So correct answer is option alpha. It will under read. 100. Main design functions of secondary surveillance radar mode S are continuous automation position reporting using GPS, improved long range communication capability, data linking, ATC surveillance, reduced communications, and TCAS. So correct answer is option Charlie. When you operate mode as transponder, you have data linking. That means automatically the transponder in your aircraft and the ATC system will communicate with each other. As a result, the need for RT communications will decrease and ATC surveillance will improve. Mode S can be used by TCAS to coordinate resolution advisories of your aircraft and the traffic aircraft. Okay, so Charlie is the right answer. I hope you have understood all the 10 questions that I have answered in this video lecture. Thank you for your time. Practice these questions again and again. Solve this sample paper on your own without looking for answers. Set a timer of 2.5 hours, not 3 hours, but 2.5 hours. In this 2.5 hours, you should be able to complete all the 100 questions, double check them, and yes, so that's it. So do all the 100 questions and then check the entire paper one more time. If you have any questions, doubts, query, let me know in the comment box of this video. I request you all to share this channel with your friends, subscribe if you haven't yet, and hit the like button if you have liked this video lecture. In my next video lecture, I will solve the next questions from sample paper number 8, and I will also come up with some new questions, new lessons. See you.